Hi, everybody. Welcome to today's webinar, Securing Agentic AI, the New Identity Perimeter. Today, we're going to be talking about how to govern AI agents, protect identity in motion, and orchestrate AI access at scale. I'm so thrilled to introduce today's speakers to you guys. We have Varesh Garg, Senior Vice President, Cybersecurity Innovation at TechDemocracy, and also Brooke Lovett, Chief Product Officer at SecureAuth. We're super excited to have you guys all participating. Please feel free to engage with us. We have an open Q&A. Submit any questions, and we'll save time at the end to get to those. And I'm going to pass it over to our first speaker, Varesh.
Thank you so much. Welcome, everyone. Thank you for such a warm introduction. My name is Viresh, and it is my privilege to be co-hosting all of you guys with Brooke. He is one of the very few seasoned experts when it comes to agentic AI related access management needs. And I am just super excited and super delighted to be participating with him. And actually, I am sure that I'm going to learn a lot from him too today. So, in terms of agenda, when we think about access management and policy authorization for agentic AI, I have a strong opinion that you cannot have that discussion, with very narrow focus on let's solve agentic AI, right? You really need to understand how your access management stack has grown and evolved because ultimately it has to fit into your overall, whatever identity and access management architecture you may have put together for your B2B, B2C, or B2E use cases. And that is why the approach that we have taken into this webinar is to basically navigate through that progression and see how new use cases came with every step of the way and how that changed the technology landscape and what we are seeing from the emerging perspective and where agentic AI is going and what new use cases it is bringing. So that's why I will start with web, the good old web, and then came the mobile use cases. Then there were application to application use cases, and now that's morphing into agent access. So I will cover the first four section where I will just talk about the evolution of the technology landscape, and that is why access management landscape. And then Brooke will get into how secure auth provides industry's leading cutting edge features for securing agents, and we'll talk about some next steps. I think in his section Brooke is also scheduled to do some live demo for us. In fact, I've not seen that demo, so I'm very excited to see that demo for the first time myself. So let's start with web access, right? So I think we all know that, what happens in the web world is that you typically have an IDP. Most customers further harden their IDP deployment these days by adding a phishing resistance passwordless component and by adding a risk-based authentication component. You ultimately get, something called a SAML token, that has all kind of attributes and group membership. Your service provider extracts those claims and maps them into the language that the application understands. And then the application itself, has a hierarchical structure, of entitlement, of policy management, where we see various models implemented. For example, in the little hierarchy that I've drawn, you will see that I have a group one that encapsulates multiple different, like there's a menu item one, there's a UI button two. So that's more of a RBAC model where multiple things are, clubbed into one. And then I also have a notion where I am saying that, the country is user's country. So which means that, you will be able to possibly go to menu item one, but the data that you will see in that menu item one is the data, of your country. So that's a back because now we are looking at users attribute, right? So this is something that we have seen for a long, long time, has been working traditionally. You can trace it back all the way to even mainframe. Some of this notion of hierarchical entitlement management you will see in mainframes, in on-prem monolith applications, in modern applications technologies, like XACML and OPA that are emerging as two parallel standards, that are typically used if you want to externalize policy authoring to a centralized product. So this is sort of overall nothing new, nothing agent here, but this is the story from where we will build, right? Let's move on from web to mobile now. So when the mobile came, basically, what happened, and I'm kind of, using some industry use cases from finance, healthcare, and retail in all of these slides, right? There was one backend web application which became sort of a backend for multiple front-end mobile applications. For example, if I look at healthcare, you might have a new mobile app that you're creating on top of your Epic web application or Cerner web application that caters to patient. You might have another one that caters to physicians, right? You might have another one that caters to your supply chain vendor for medical devices, right? I'm not going to talk about all the use cases on this slide, but ultimately the idea was that this is the modern age of BYOD and smartphones and tablets, and mobile applications became very prevalent, and now there was need that on top of applications that already exist, can we mobile enable them? With that use case, the primary security requirement that came was that although you want to mobile enable, but you want to probably give less permissions in mobile app compared to web app, right? As an example, let's say you have a financial analytical app and you may not have a DLP product deployed, on the mobile phones or tablets. So you may not want them to allow to download the general ledger, PDF or Excel file on the mobile device, while you may allow that on the desktop because you have the DLP policies installed there, and that data will not be able to be exfiltrated, right? That's a perfect use case where you might want restrictive access on mobile, right? So so restrict to less functions, restrict to less data. You may not want someone to, let's say, change the forecast data on mobile device, right? Just only view it, right? And even on the view, you may want them to have restricted view, that they can do more granular view on web, but more restricted on mobile, right? So with these use cases, the key requirement was that I'm not going to change my backend app, right? Maybe the backend app is as legacy as mainframe. I cannot even change it. So how can I introduce these new restrictions in such a way that it is plug and play and it is an overlay on top of my web use cases? And that, that's where OAuth came into picture, and OAuth became extremely popular because now in that use case, when the user goes to mobile application, right, the user gets something known as an OAuth token from their, OAuth server, which delegates to the same IDP. But now in that token, right, there is claims, and claims based authorization. So now in these authorizations, you can say that I am not going to allow this API call, or I am not going to allow, you can even look at the payload of the data, and then you can say that I'm not going to allow API call with this data. You can even, when the response, let's say someone says, give me data of all customers, and maybe on web you are allowing, someone to view all customers, but you can say that in mobile, I will only allow, in one city at a time, right? So you can do redaction where, although the backend application is giving you customer list of the entire country, you're redacting it to, only one city, or maybe you are redacting PII information, etc. Because again, you may not have the DLP on the mobile phone, right? So, basically in this architecture, OAuth got introduced that brought in some new infrastructure, specifically the OAuth server, that generates the token, and the API gateway then, that extracts it both for mapping purposes as well as for the authorization and response redaction. So this enhancement basically introduced a new technology, and mobile enabled are already written web applications. Let's move on to the next, technological advancement that happened now, right? So now, what customers wanted to do was, there were already multiple applications written, and the word became all about facade applications, which mean that user will not have this abrupt switch over, that I have to go to this app to view this and that app to view that. And the idea was that user can stay into one app and get data from multiple locations and look at all of that, in one place, right? I'll give you an example, right? A perfect example of that is a telehealth app. Let's say, you go to one hospital for your primary care, you go to some other hospital for your endocrinology care, and you go to another hospital for your ophthalmology care, and you go to another dental office, right? These are all different. These are all going to be, even if they're all epic, implementations, they are going to be their own each hospital will be another tenant in the epic, right? Let's say you have a telehealth app and you want to integrate with all of them and get data from all of them, for example, upcoming appointments and notes, right, into a telehealth app. You can, now configure that telehealth app, right, to be acting on your behalf and calling these multiple EHR systems and sucking in that data, right? Another example that is not on this screen, but it is very, very common, we all use it, is that, if you upload a picture on Instagram, if you also want it to show up on your Facebook feed, that's what you do. You give authorization to Facebook to look at your Instagram feed, automatically on your behalf, right? So you basically, give that authorization, you give an OAuth token to Facebook, and it uses that token to continuously fetch your feed from Instagram, right? So this is, the next generation where it's not one application which is mobile enabled, it is multiple applications that then become sort of a, one of them becomes a facade that gets data from multiple to aggregate it for you, so that from usability perspective, you're bringing the integrated view from multiple places, in a cohesive fashion in one application. From the implementation point of view, it did not bring any new technology. It's the same thing that you are seeing here. Again, you did not want to make any changes into application, and whatever, technology was introduced in, the mobile use case also applies to it. So if you look at sort of, just the functional diagram, user, is going to application one, and, basically telling application one that now it can call application two on behalf of user, right? So an OAuth token is generated, given to application one. Now the user is not involved. Application one uses that token, and fetches the information on behalf of user, what user consented in the OAuth, token generation time. And then in the same way as I was showing before, the API gateway comes into picture, that, does the claims based authorization. It can do the redaction, it can also do the extraction and mappings. Exactly same sort of workflow as it was in the first use case, except there is no user involved now. It is, complete application to application, sort of interaction. So now let's make it more interesting for, one of the questions that a lot of customers ask me is that we already do application to application communication, right? Why is agentic AI any different, right? In agentic AI, the agent is an application calling another application, right? So why is any difference or any new technology required, where, an agent is now making calls on behalf of user or another agent? Why is that pattern not exactly the same as what I described application access? So let's get into a little bit of detail of that, right? So I want to explain you that by three key trends that I'm seeing, that make AI agent communication to be very unique when compared to application calls that I just described. So the first use case is, and I'm going to explain it, with, my healthcare example, right? You could have a wearable app, for example, Samsung has a wearable app. If you have Apple Watch, it has a wearable app. And you can, create an OAuth token so that in the wearable app is able to upload your data into Epic, so that doctor can see everything that Apple Watch is capturing for you, right? This is an application to application flow, right? You do not need, this is not agentic AI. How the agent is changing that flow is that now agent is doing the same thing, but you want agent to be acting smart, right? For example, if you have a doctor appointment coming up in 1 week, maybe you want to upload daily data. If you have a doctor appointment that is only going to come in 3 months, maybe you want to only upload monthly data, right? Similarly, if it is data about how many glasses of water you drank every day. Maybe that's the data that you want to send to your primary care physician and your endocrinologist, right? But if it is your some other markers, maybe they go to that specialist, right? So you want the agent to understand the context of what data is being sent to which doctor, and what's happening overall in that context, and make smarter decisions, right? So now you may say that if the appointment is 3 months out, the agent will not send daily data, right? Because that may flood the number of notifications that the doctor is going to get from those epic uploads, right? So this sort of what an agent should do is becoming a very dynamic policy, rather than only focus on what user allowed to do, which is to, yes, I want to share my data with the doctor. It's becoming intelligent based on the context, on what operations agent can perform or cannot perform. So I call that attribution. Now let's look at the second use case, right? In the application to application, I have the same narration here. So now what we are saying, actually, I kind of talked about this before, right? Hey, you are sending the data to an ophthalmologist, right? He may not care about how many glasses of water I drink every day, right? But my endocrinologist may care, right? The wearable devices are also capturing, my heart rate variability, and my glucose level and other things right now, which my primary care doctor and my diabetes doctor may care, but my psychiatrist may not care, right? So now, based on the data, right, the data being which biometric is captured by wearable, you're making an intelligent decision on who to send and who not to send. So that's basically called a database decision. So that's delegation, where you're following the lineage of data and you're making a decision based on data. So that's also more dynamic in nature, right? The user is not defining all these policies, but someone is defining these policies in the background, that based on this scenario do this. And I think the key thing to understand here is that typically in an application, right? A user, if the user was performing these operations, users are generally very smart. And in addition to the authorization, they apply their tribal knowledge and wisdom to understand that just because I can do it, should I do it? Right? And basically, if you look at these use cases, they are mimicking that in the agent world, right? Just because an agent is acting on behalf of user does not mean that that agent should do everything that a user should do. Just like the user is intelligent, that depending on the scenario and data, the user makes intelligent decisions that the user has learned, and has tribal knowledge on what to share, when to share with doctor, what to share, when to share, in other scenarios, right? You're making agent smarter, and you're also making sure that agent is not crossing the boundaries and making mistakes, right? So you are kind of making sure that you're playing in the safe zone. So that's what it's all about. The last use case is also very interesting, right? So when I talk about the wearable app and the Epic app and app to app interaction happening there based on OAuth that I described previously, in that case, the Epic app existed and the wearable app also existed, right? So when you define app to app OAuth sort of flow, both applications physically exist, right? But there are these new scenarios emerging where the wearable company may say that, hey, I'm going to give you 1 year free access to your data in cloud, and I'm going to give you 10 other features if you consent that I can anonymize your data and I can share it for research and marketing, right? And I've given my general consent. So now what this wearable company wants to do is to actually define policies for agents that have not even been thought through right now. It's just a logical concept. It physically does not exist, right? So you are safeguarding this data against future use also, right? So you are saying that any research application that will come in future, I'm going to do things like that. So the agent, when it will be uploading data to any research applications, any new agent that will be written that will upload to research, any research application, it will follow these kind of, it will anonymize the data, it will not send PII. You can define all of that, although the agent does not exist, and maybe even research application does not exist right now. So I call that ephemeral use case. So if I summarize these use cases, right, in the traditional sense of app to app interaction, it's a static grant. Whatever user said, that's what application one, the client application, can always do on the server application, right? Same function on every context and all data set, and the application has to be existing. Those are the keywords. And the future is where the agent may be existing or future, right? And the grants are dynamic. And they not only factor in user consent, they also factor in the dynamic policies, which are a function of overall context of what are you doing, why are you doing, how are you, why are you here, right? And the data that you're operating on. So again, the access changes from static to dynamic based on who is agent acting on behalf, why is agent doing it, so that there is that contextual attribution. Again, the second is that the consent applied to all data, and now, based on data, the policies can change. So, that becomes, more delegation based on the data. And then, I described the ephemera. So those are the three key use cases that I have generally seen where customers come to us at Tech Democracy and tell us that, the stack that I have right now, the one that I built for web, the one I built for mobile, the one I built for app to app, very mature implementation of OAuth, XACML, OPA, etc. Right? That's not good enough. I need, a solution that kind of caters to these use cases, and that is where I see the emerging need for MCP layer. And that was my last slide, and I will hand it over to Brooke now. Brooke, please go ahead.
Thank you very much, Varesh. Wrong slide. Okay, so there's a fair bit of ground that you covered there, and I think that watching the journey evolve from kind of where we started and how these OAuth tools and how the various patterns for what we know as zero trust essentially today have become the scaffolding upon which we're building our agentic setup, right? I think what I would like to do now is dive a little bit deeper into how the technology actually works and how we actually implement it today when we're actually doing these things. And so I'm going to showcase some of SecureAuth's technology here, but a lot of these concepts are relatively generic, and certainly they are open standard supported. So let's look at the case where we have an AI agent acting on behalf of a user. So you'll recognize the diagram here. It's the same one that Varesh was speaking to. The orange components are things that have kind of changed from that drawing. So I will scribble on here as we go. So the biggest thing here is that we have a user interacting with something called an agent, right? And this agent is an application technically, but it's an agent in that it has some autonomy and that it can do things and it's dynamic. And so some of that ephemeral nature and the fact that things can change on the fly is what Varesh was referring to. Now, as far as the IDP, when a user is acting is operating an agent or operating an LLM chatbot or something like that, the user is the user and they have to sign in. And here we have an IDP that covers that sign in. SecureAuth, of course, can be that IDP, but we can also plug into whatever IDP you're already using. So if you have a system using, Microsoft Entra or you have Okta or whatever, those things can all be used for this, but you need to extend that capability to get the feature and function that you need to really address the use cases. So the idea here is that the user authenticates and authenticates to the agent and authorizes transactions via their IDP. Now, once the agent has their token, now the agent on this drawing can operate through the proxy. They can get to MCP and A2A gateways, right? That's Model Context Protocol and Agent to Agent Protocol. There are 5 or 6 other protocols out there that will allow these agents, arms and legs and appendages to actually get stuff done. Now, when the agent makes these requests through the gateways and so on, they actually need to get, whoops, I'm scribbling on the screen here. They actually need to get permission to do that, right? A lot of times they're accessing private data or they're accessing data that, or accessing an API method that would do something sensitive. So in order to make that work, we have to apply access control at the gateway. And we do that using the standard patterns. We use a policy enforcement pattern where the enforcement point is actually inside the MCP gateway or somewhere thereabouts. And we have a PDP element of this where the decision point can be externalized and it might run at or near the MCP gateway, but it is actually controlled by an administration point. Again, SecureAuth provides this. There are other vendors that can do it. And what we're using to do this is not just your standard role-based access control or attribute-based access control, but also token-based access control, relationship-based. So based on like the Zanzibar graph, for example, and other FGA technologies that are in there. And token exchange is a critical component of this. And I'll get into what token exchange means here on the next slide. Now, when we talk about the concept of zero trust, I think there's been kind of a bit of a misunderstanding as far as what has happened with zero trust. It's no longer like the focus of the talk track that people are using, but certainly it underpins what we're doing with agentic infrastructure, right? It is the architecture on which agentic AI must run. Otherwise, we're going to have a problem because no one will be able to see what's happening. We won't be able to control what's happening, and we will kind of lose that observability that we have in today's world. So if we look at this drawing here, the top part is like the public cloud infrastructure where the IDP exists. In this case, we're talking about the Secure Auth IDP. We have an agentic infrastructure down here at the bottom. This is where your actual agent infrastructure is running. This could be in the cloud. It could be in an IaaS platform. But for the purposes of this discussion, we'll just say it's on premise at a business, right? So you have a user, can be anywhere. The user is going to access the agent, right? Number one. And in order to do what it needs to do, the agent will end up asking for permission from the authorization server, which will result in a redirect that puts the user through number two, where they have to sign in. This is the IDP SSO that occurs in all of your day-to-day interactions with any application. That might go through multi-factor, might go through a risk check, but ultimately what happens here is in number three, the agent gets a token that represents you as the user, and using that identity and using the permissions encapsulated in that token, the system can then call out to private data sources through MCP servers and the like, and it can get access to those systems if the PDP, in this case, our micro perimeter authorizer, which is a component of the Secure Auth IDP that we can deploy at your, at or near your point of service. So at the MCP server, and I'll actually show you this live in a second here. And once that decision is made, it is audited, and all of the synchronization that occurs here is one way, right? So you don't have to punch any holes from the service down into your agentic infrastructure. You only push information up and pull information down over that same channel. Now, once the agent has the private source data, it can then use the cognition available in a public LLM or a private LLM in order to make decisions and do things, right? And that private data and controlling access to it is really the scariest part for a lot of our customers today. Now, one more thing before I pop into kind of a live demonstration here is we have this concept of token exchange. Now, token exchange is, and some of you might know it as the on behalf of flow in OAuth. The idea here is that if you have a user asking the agent to do something like get private data or do something that requires access to private data, the agent might be able to do that on its own autonomously, but it needs the traceability of saying that this user told me to do this, right? The same way that you don't want to be blamed for what an agent does autonomously, the agent doesn't want to be blamed for what the user is telling it to do. And it's important that we have that observability across the platform. So in a token exchange operation, the user would authenticate, the agent will get a token that represents the on behalf of authorization. So the user is operating the agent is operating the MCP server on behalf of the user. And therefore, we're able to trace what information was shown to and used by which users, right? So pretty basic, but fundamental concepts. So let's look at how this actually works. All right, so we have built a very simple agent. You'll see that I have two browser instances open here, and I'm going to show you kind of how it works first, and then we'll dig into the product and see kind of what actually happens in the configuration. So this is just a very simple agent. That's what we're calling our finance assistant. So the first thing I'm going to do is I'm going to sign into this agent as a user who has permission, or it exists inside of this finance group, which will get, this is test user one, which will get a certain amount of permission to operate the agent. We're going to sign in with passkey, and this will get us into the system. And we now have access to our chatbot here where we can ask finance related questions. If we take a quick look at the token, what you'll see is that we have a regular access token here, but it has been able to get scopes. This indicates that I have cash balance permission and payroll liability permission, right? I can look up information in certain methods, and in this case, we have MCP methods tied to these scopes, so that I can actually do things with that information. So if this user asks, question like, how much money do I have in the bank? it should be able to answer that question pretty specifically, because it's going to be able to look up the information, and it tells me that I have exactly this much money. I have payroll liability, which it went ahead and looked up for me, and it tells me exactly what I have after that payroll is paid, right? So it's able to tell me very specific information because those MCP methods were executable. If I log into the same exact agent, but I log in as a different user, we're going to use user 2 here. Now, this user is not in that finance group, and I'll show you kind of what that means later. But the ultimate result is that the scope array here, even though those scopes were requested, the scope array does not include either of those things. And if I ask the question, how much money do I have in the bank? It's not going to be able to tell me because I'm not authorized to access that information. Okay, so let's look at what actually happened. So inside of our platform, we're kind of mapping the whole infrastructure here, right? So on the left-hand side of the screen, we have the identity sources. So we're using one of our own internal IDPs here inside of the product. We have our own authorization provider. This is where we configure our scopes and our token exchange and our consent settings and so on. And we have this AI finance agent. And this finance agent is able to access 3 APIs through the MCP server. And so if I look at what these APIs are, they are to disperse payroll, which requires CFO access. You can get the payroll liabilities, which requires that particular scope. And you have the get cash balance, which requires that particular scope. Now, in order to get a token with those scopes, you have to actually be able to get authorization for those scopes. And we're able to provide a specific authorization for an individual scope. So if we look at these scopes, we actually have one called CFO access, cash balance, and payroll liability. And they have different policies attached there as well. So only the CFO can get CFO access, and only people in the finance group can get to the payroll liability. And if we go just quickly look at our users, which are down here, we will be able to see that in this group, in the finance group, test user 1 is there, but the test user 2 is not. And that's why when the test user 2 signs in, they don't get access to those scopes. Now, in addition to how you get the token, we're also talking about authorization that occurs at the MCP gateway, right? And so the way that works in the platform is we have authorization gateways. And these gateways, if you were to create one, these are designed to hook into service meshes and AWS API Gateway and Apigee and Kong and things like that, right? And we're using the standalone version of this, which is simply a Docker container, in order to represent, the future of what an MCP server would need, an A2A server would need. So I configured one here called the MCP Finance Gateway. I ran our quick start, which essentially just downloads a Docker Compose file. I ran the Docker Compose file and connected the APIs. And it actually, when I connected it, discovered that I have these 3 elements here, or these 3 APIs available. And once those are available, then they show up over in this screen, and you can start attaching policies to these. And you can see that I have a weather service. I have different services that we've created. Now, what's really interesting is that when this thing is operating, you can actually watch the requests happening. So if we look at the 2 that were successful a minute ago here, these are the checks that are occurring. And these are the endpoint checks that failed, right? So if we're monitoring what's going on with this endpoint, and we go back to our agents for a second, if we opened up, let's say if we open up these, let's lock down one of these guys. We'll make you unrestricted, and we're going to make you unrestricted. All right, and what will happen here is that the configuration, which is running on a separate server, this is outside of our SaaS environment, has updated its configuration. And now if I access, even as the user who didn't have access before, and with a token that doesn't have those scopes, this user can now get at that private information, right? So it's as simple as that. So let's reattach those so that it will work going forward. So payroll liability, and this one was cash balance. Okay. All right, so that's the first pattern. So let's go back over to our slides. And we're going to talk now about autonomous agents. Okay, so now in a situation, what we've just seen is a user operating an agent, right? And we're controlling the way the agent is able to access things based on the user operating that agent. If you remember on the previous slide, this was step one, where the user accessed the agent, and this was step two, where the agent accessed the data for the user. In this case, it's the opposite. Number one is the agent attempting to do something autonomously, or perhaps from another user or agent's invocation, right? So you could have a recursion here that's occurring. You could have agents calling other agents, but ultimately the person who needs to approve or authorize the transaction is not in the loop, right? So step two here is literally to bring this person into the loop. Now, we have technology that allows us to do this already in the open standard community. We have specifically something called CIBA. And CIBA is client-initiated back-channel authentication. This is actually part of the financial grade API specifications, which is called FAPI. You might have heard of it called FAPI. The idea here is that the user, while they don't have any interaction directly, like you'll notice here, there is no direct path between the user and the agent wants to do something. The authorization server needs interaction with the user, and the user needs to interact in order to approve that transaction. And the MCP or the agent is then, once they have that permission, able to access private data information through MCP and use it to operate the LLM, or perhaps the agent is an LLM, right? So the idea here is that you want to be able to bring the human into the loop, and we find this to be critical when it comes to real world use cases for how we do this kind of thing. So I'm going to do a secondary demo here, and for this one we're going to use Claude. Now this is just a standard installation of Claude, and I have an application that we built here that is running. Obviously, I'm screen share from my phone, right? I'm signed into this app, and I am, a kind of super administrative approver. I'm signed in as the CFO, so I have access to CFO access, and I can like disperse payroll and all that sort of stuff. And over here, this setup here is actually configured for some MCP methods. And all you do to do this is you literally tell it where the MCP methods are, and it reads the comments in the beginnings of the methods, and it learns how they work. So if we were to look at these, you'll see that step one is it tells it how to get a token or how to initiate the approval. Step two is once the approval is retrieved, then it can get a token. And then these all require input. So if we take a look at what that actually looks like, it literally is comments, right? So step one, I gave it this comment, and it should know, right? And this is how MCP works, right? You're annotating these tools. You're using a step two here. This is the second step, right? You need to call this every 5 seconds, and don't do it longer than 2 minutes, right? The LLM will be able to figure this out. So if we ask this thing, I'm gonna tell it to do something urgently, right? So we're going to tell it, I need to urgently run payroll. Please help. And we're going to bring back this guy here. So what's going to happen is it's going to figure out what it needs to do. First thing is it knows that it needs to call and get request information from the CFO. Now you'll see while it's typing over here that a message has come up in my pending approvals here. I'm going to go ahead and approve that. And when I approve it, the next time it checks, which will be just a second here, it's going to see that I did approve. You can see the CFO has approved. And now using the access token that it was able to get through that transaction, it will be able to check my balance, see what the payroll is, and make sure that I have enough money to pay it before it actually runs the payroll. Now, Claude's not the fastest localized LLM here, so this thing will take a few seconds to run through. While it's doing that, we can also look at this. So here I have the gateway that's controlling access, and you can see here what this right here is the authorization, right? We got authorized to get at the finance server. This one got the cash balance, you can see, right? And then we can see the result here. It actually got that we have $5 million available. Things are looking good, right? And the next thing you see once it gets its act together and calls the second method here, will be another one, and that one will be for get payroll liability. And once it does the calculations, it'll be able to figure out if it can pay the payroll or not. Now, obviously, this is not really doing anything because the the MCP methods are returning information that's not real. Oh, it was unauthorized. I might have there. Okay, so this is actually a good use case, right? So it wasn't able to see how much the payroll is. And it's telling me that it wasn't able to because it got some kind of an error. So let's go ahead and process the payroll now, even though it wasn't able to get at that information. I probably broke something when I did the previous demo. The interesting thing about demonstrating with an LLM is that they're different every time you interact with them. So here, this one is actually dispersing payroll, and it was authorized, and payroll was successfully processed. And it tells us what was completed. So none of this is canned, right? All of this interaction here with this LLM is the LLM just interfacing with us, right? We got an out-of-band approval from the CFO, and that approval was accepted. And the LLM knew and was instructed to check back to see if the person had approved. There's also a pattern where you can do a push there to make that a little bit faster. Okay, so let's go back to the slides for a second. So in this case, if you recall, the user didn't interact with the agent. There was a user, right? But it was a different user. So this user, that was me typing into the agent, hey, please go run payroll, right? And in this case, the LLM and the agent are the same because this is a chatbot agent running an LLM. That's what Claude is. And the agent was able to request access via number one. The authorization system contacted the user by pushing a notification to their phone saying, hey, I need you to approve this. And the user was then this user, the CFO, was able to approve that. And once the agent got the token, it was able to go and get the bank information and run the payroll. So pretty straightforward. Now, what's important about this is that this isn't something proprietary that we just made up, right? This is an open standard implementation. So what this looks like inside of the platform is pretty much canned, and it's in the it's in our documentation. So you can go to this the documentation and search for SIBA, and you'll find it. And there's like a step-by-step setup for how to do this, right? In here, you're going to go to your authorization server settings. You enable SIBA. You give it the endpoint of the authentication service that you want to drive the push. Ours is SIBA. It's running out in AWS somewhere. And you are then able to go to your applications, like your AI finance application. And when you give it grant types, instead of just authorization code flow, which is what we used for the first part of the demo, where we were doing the agent operating on behalf of the user, you add a SIBA grant type. And the SIBA grant type gives us the ability to do the human in the loop flow, but it gives us the ability to attach to the scopes that we needed. So in this case, it was the CFO access scope that we use to disperse payroll, because you need that in order to run the payroll method. All right, so with that, I'm going to bring the slides back up, and we will talk about next steps.
Thank you so much, Brooke. What I hear from customers often is that one, I don't want to touch what's already working, right? Second thing, for all these complicated use cases, I don't want my developers to be writing code all over again where the permissions and policies are, written as code. And, I want it to be done declaratively. I want to make sure that my existing applications, do not break because of whatever new I do, right? So like these are typically the things that worry customers, to do access management on agentic AI. And it was just really, really refreshing to see that you hit 10 on 10 on all of those goals. So thank you so much for such an awesome demo. So coming back, folks, Tech Democracy, we are proud to be in this business for 25 years. When it comes to access management, we do provide end-to-end services. We are a one-stop shop. You can hire us for advisory services to, do your architecture assessment, business case roadmap. implementation, managed services, its overall integration with cybersecurity, etc. We do B2B, B2C, SIAM, and B2E, and now there are agentic AI use cases coming in all of those three domains. So we provide, we have extended our service. Yeah, no, yes, thank you, Brooke. Yeah, so I think from the next steps, you know, uh, jointly we and Secure Auth, we are offering free workshops to customers for agentic AI needs, and in those workshops we will focus on understanding whatever you currently have, understanding what are your agentic AI needs, everything that Brooke covered and I talked about. How much of delegated lineage based policies do you need, how much of attribution do you need, what's your agent life cycle in terms of their ephemeral and dynamic nature, etc., etc. And in those workshops, we will at least give you a high level solution architecture for how secure auth will overlay on whatever you have right now, right? No rip and replace, no changing whatever is working already, and using secure auth as a sort of, in this particular case, a point solution solving agentic AI use cases, as a bolt on overlay on whatever you have without any disruption. So we hope that some of you will reach out to us for taking advantage of those workshops. You can also, we also want to, this is a topic that is going to continue to emerge and evolve. So I would love to hear from you in terms of your recommendations on, what do you need from us in terms of thought leadership, white papers, and additional webinars, and what topics would you like us to cover so that we can continue to collectively grow, and share the collective wisdom of the fraternity with all of you guys. And I have some email addresses here. I hope to hear back from all of you. Thank you. Over.
So I actually see one in the question list here that I want to call out straight away, Varesh, because someone's asking, is there native support for behavioral analytics to differentiate anomalous activity from expected agent behavior? And I think that this is actually a really important topic. And so what I want to do really quickly is just bounce back into the console here. So everything that I just did for these demos is tracked in our central auditing. So here you can see every event that occurred, right? All of the access requests that were done, all of the policies for granting, for example, access to, you can see this one, is an example where we're getting access to the scope grant, right? And it's basically checking to make sure that we can get a user can get cash balance scope and making sure that we're part of the finance group to do it and whether or not that was authorized. You can see how the authorization code was created, the access token was created, and then every time that that token is used against one of the gateways, this information is actually coming from the satellite agents, like from the policy determination points. So suffice it to say that the information is there. We provide analytics on what's happening there. So you can see the enforcement that's occurred like over the last hour. Like this is what we just did like inside of the demo period, right? We can look at the risk insights for the users that authenticated during that time. And if you want to do further analysis, all of this information is available to you. Like you can look at any of the metrics across anything that we're doing, the authentication summaries. You can see that I'm in South Florida here. All of this is available via APIs, and you can also set up webhooks so that you can point any of these events. Like you can send only risk information, or you can send all of the information, or you can send only gateway requests. So these would be like the MCP request and denied out to your system so that you can actually perform your own behavioral risk analysis, or you can use ours to make decisions. So that's probably the first question that I wanted to hit there. We have a number of them. So I'm just going to go through kind of in order here. So in no particular order. First one, or second one rather, is how can you best explain the business value of securing AI agents to someone who isn't technical? Well, I think that the easiest way to describe it is you have to secure agents that have a level of autonomy the same way that you secure identities, right? The difference between a human and an autonomous agent is simply that the human has an intrinsic physical identity that can be proven, with government bodies, right? We don't really have a way right now of identifying an agent other than to say, we have a signed piece of software and it exists in the business ecosystem. So I think to some degree here, we have to treat these things as if they can do all the things that humans can. And in today's world, the value of doing it is that the cost of not doing it is ginormous. So I think that's probably the easiest way to explain it to a non-technical person. The next one is, how does your platform handle real-time access orchestration for agent-to-agent interactions, especially event-driven systems where AI agents make authorization calls without human intervention? So another great question. I think we, to some degree, addressed this with the Siba demo, right? So in that case, I was operating Claude, right? So if we look at Claude, I, as the end user, said, "Hey, we need to run payroll," but it got a human out of the loop approval from the CFO in order to do what it needed to do, right? So imagine a scenario where the LLM or the agent in general is operating autonomously. It can still send the CFO a message on his mobile device while he's on the golf course or she's on the golf course and say, "Hey, I need approval to do XYZ," and the person can still do that approval, right? So I think that orchestration and that kind of just-in-time access control that needs to occur there, which is case by case and can be, um, decided on at the time by the approver, is something that is already possible, right? So that's how our platform handles it, but it's also an open standard. So you'll find that there are reasons to kind of use the open standard there, in that that it's tried and true technology that's used across multiple open banking jurisdictions and different FAPI implementations around the world, and that if it were to break in some way or someone found a vulnerability, that the community at large would fix it, right? So our recommendation is to stick with open standards wherever you can. Let's see, we got another one here. There's some good questions in this list. How do we extend our current identity governance policies like SOD, least privilege, or role-based access to autonomous agents that don't map to human behavior or business roles? That is a great question also. So I think that when Viresh was talking about the ephemeral nature and dynamic nature of the identity, the thing that we need to remember is that an agent is going to change over time, right? Its capabilities will morph. Like even it can have a different version from one day to the next, but its identity doesn't change. So I think that it's best to think in terms of least privilege rather than role based here, where you basically say the system has access to nothing unless it can prove a direct relationship or indirect access relationship with that object, and or has gone through a specific approval or attestation by someone who does have access to allow it to work. And that observability and that traceability is pretty important. I don't think that segregation of duties is going to really work as well as it does for humans here, because you can't separate the capabilities and functions of one agent from another, right? They can group together, they can spawn other agents. I think that it's important to keep in mind that the physical properties that separate two humans don't really exist in the computing world for agents. So my thinking is we use the principles of least privilege, we adhere strictly to zero trust architecture so that we're checking every access, and we don't try to map to human behavior or roles, but rather we use relationships of objects and use things like Zanzibar, which gives you kind of relationship based entitlement mappings, where you can give people and things direct access or indirect access with particular permissions and entitlements to particular objects en masse without like using directories or databases to do it. All right, next question. What's the fallback strategy when an AI agent fails a trust check or behaves unpredictably? I could do a whole webinar just on this topic. I will try not to be too long-winded here. We have this problem right now, right? So people are building agents inside of companies, and inside of your company, you generally will issue, an identity to an agent the same way that you use MDM, right? You're going to have like a private key generated by the agent. The agent can dynamically establish its access with here. Let's stop the screen share. it can dynamically establish its identity with the authorization server, and it can get access tokens to do things. Now, the important thing about that is that you need to be able to revoke that identity. And if you are inside the enterprise and you can revoke the certificate that's assigned to the private key, or that's generated by that private key, you can stop that entity from interacting. Now, if we zoom out and we talk about agents that are operating inside of an enterprise but need to access other enterprises or something inside of an ecosystem like that, now we have an issue that hasn't been solved. And it's the same issue that I was talking about before, where the identity of the agent is not something that is like assigned at birth by the government like it is for a human being. It's something that's assigned by the creator of that agent, and that agent can create more of itself, right? So what we need is a trust framework. We already have this technology in open data and open banking jurisdictions, but we need to be able to revoke as a community if an agent does something weird, right? And so an example that I use a lot is, if I have a travel agent that's working on getting me cheap flights and it goes and tries to DDoS the American Airlines site in order to get a better price, it needs to be taken out of circulation, right? Because you can't have that happening. And the only way to do that would be by everybody trusting like a single registrar that kind of says, okay, these are the agent identities that are trusted, and these are the ones that have been like, revoked or CRL'd out of that list. So I think that's a big topic, and I think that the fallback strategy is probably to disable agents that act unruly. Okay. Given that we only have 2 more minutes, there's a lot of great questions here, everyone. Thank you for the questions. We will try to answer these out of band. I'm gonna go ahead and put up the very last slide and hand it back over to.
Thank you, Brooke. Thank you everyone for joining this session. It was a really great session, and you will receive the assets for this webinar in your inbox to further explore the capabilities. We appreciate your time, engagement, and interest. If you have any further follow-up questions, we have taken a note down of all the questions that are pending to be answered. We will reach back out to you with the answers to those. And you can, if you wish to contact us, you can see the contact coordinates on the slide mentioned. You can reach out to us on this. And until next time, stay secure, stay forward looking. And yes, you will receive the recording as well as assets for this webinar in your inbox soon. Thank you. Thank you everyone for joining.
Thanks all.